What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are continuing our Khan Academy SAT Digital Math series. And we are moving on to Quadratic and Exponential Word Problems Level Foundations. And if you're new to these streams and new to this channel, we're going to knock through all of these critical concepts using the Khan Academy series while I solve 4 problems for the first time in real time. And I'm going to explain the problems as I go through. Problem walkthroughs, in my opinions, are the best way to learn. So without further ado, let's do it. Here we go. P of t equals this. The equation models P, the amount of bacteria in a colony forming unit, blah, 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 T hours after growth. Which of the following statements is the best interpretation of the order pair 2, 496? So before I even look at the answers, let's talk about it, right? So we've got 2 being the T value, right? Because it's a function of T. And 496 is P, meaning the amount of bacteria, the population. So what this is saying is when T is 2, meaning 2 hours, in 2 hours, the population will be 496 for this bacteria colony. Okay, so I like to do that first before I even look at the answer choices, get my answer formed in my mind, understanding the breakdown of the situation. So now let's see, there are 496 colony forming units in the bacteria culture. Wait, amount of bacteria colony. Oh yeah, it's right here. I just didn't read the full language. Bacteria in the, so the amount of bacteria in colony forming units. So yeah, that's 496 colony forming units. This is such a weird way to state it. There are 496 colony forming units in the bacteria culture after 2 days. No, wrong. That's not the unit, right? We said it was hours. Oh, my computer's kind of glitching. Hope it's okay, guys. The number of colony forming units in the bacteria culture reaches 496. No, not generations, and then not 496 minutes. That's completely backwards. So anyways, A is the winner. Done. All right, next. All right, next. Here we go. The function models F, the value of a professional quality video camera in thousands of dollars, T years after its purchase. What is the value of the camera at the time of purchase? All right. So we're talking about value of camera at the time of purchase. We're talking about initial value. And the easiest way to think about initial value is when the variable, the time variable in this case, is equal to 0. So all you got to do is plug in 0 for t, and anything raised to the 0th power is 1. So that goes away. So we now know that it is 14. But remember, this is in thousands of dollars. So it's not just 14, it's 14,000, which means B is the winner. Done. Okay. Next, we've got this one. A shoe manufacturer determines that its monthly revenue in dollars is given by the function where Q is the number of pairs of shoes sold each month. What is the maximum value of the company's monthly revenue in dollars? Okay. All right. Sorry. I hope that I feel like my computer is getting a little laggy. So let me know in the comments if anything is seeming weird. Okay. So, all right, a shoe manufacturer determines that its monthly, okay, sorry. What is the maximum value of the company's monthly revenue in dollars? All right. So if we're talking about maximum, right, and this is a quadratic, okay, the max value is going to occur at the vertex. So we can, this is actually in vertex form, but if you're not sure about that, right, you can always plug it into Desmos. That's the beauty of Desmos. But since it's in vertex form, this is my A value, and my vertex is the X value, which is the opposite of this value, which is 260, and the corresponding Y value of the vertex is 9,500. So the maximum value occurs at this point, meaning the max revenue is the second value. That's the revenue value, 9,500, and it occurs when shoes equal 260. But it's asking what's the maximum value in dollars. So that is the second value, the 9,500. So 9,500 for the win. Done. Okay, last one. Here we go. The function models. Oh, all right, cool. So the function models P, the amount of bacteria in colony forming units in a bacteria culture, T minutes after of growth. How many colony forming units of bacteria are in the bacteria culture after 90 minutes? This is a straight plug and chug situation. We've already said that T represents minutes. So all I got to do is plug in 90 for T and evaluate, okay? So I've got 30 times 2 to the 90 over 18. Now I'm going to do this without a calculator, but you're more than welcome to use a calculator. Again, the entire digital SAT allows a calculator. 90 divided by 18 is, of course, 5. So it's 30 times 2 to the 5th. 2 to the 5th is 32. And then 30 times 32 is, let's see, 960. Okay, so now they threw a little twist in, right? They didn't give us that exact value of 960. They gave us these things. Well, 3 times 10 squared, that's 300. That's out. 5.4 times 10 cubed, that's 54. Wait, no, sorry. That's times 1,000, so it's 5,400. That's out. 2.43 times 10 to the 7th, that's huge. We're not even going to tell you. So it's this, 9.6 times 10 squared, which is 9.6 times 100, which is 960, which is what we calculated. B is the winner. Done. All right, guys, that is it. I hope you guys liked this video. If you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. And again, we're going to be knocking through all of these topics leading up to this March SAT. So I hope you'll join me on this journey. I think it's going to be really useful and beneficial. If you are looking for the best digital SAT platform for preparation out there, check out the SATcrashcourse.com. All right, guys, thank you guys so much for joining, and I will see you in the next video. Take it easy.